to True Projects. In this video, we are going to explain about a project titled Heart Disease Prediction using Vision and Deep Learning. The significance of the heart within the human body and the intricate network of the blood cells constituting to the cardiovascular system are underscored. Furthermore, the profound repercussions of the heart disease on the healthcare landscape and the global mortality toll are illuminated. This accentuates the urgency for the precise prognostication and the diagnosis of the heart condition, particularly in the less developed region where the medical resources be limited. In response, the proposition of harnessing the potential of machine learning and the deep learning algorithm emerges as a promising avenue for the precise heart disease prediction. This initiative aspires to a substantiate contribution to the medical domain by introducing a model capable of early accurate detection and analysis of heart elements, potentially transforming the healthcare outcome by enabling the proactive intervention. And the primary objective is to create a heart disease prediction model, employing both the machine learning and the deep learning technique. This model seeks to offer the precise forecast of heart disease through the examination of a dataset comprising of 303 instances and 14 distinctive attributes. The incorporation of computer science and artificial intelligence within the medical realm is highlighted as a critical means of preserving life. Furthermore, an analysis is conducted on the dataset to unravel the intricate attribute relationship. The overarching goal is to enrich the medical domain by introducing an advanced model capable of early accurate heart disease prediction, thereby fostering the proactive medical intervention and the potential transforming patient outcome. And these are the basic requirements that are needed to build this project. The software requirements are Python IDE with version of 3.7, Anaconda with version of 3.7 or Jupyter Notebook. Hardware requirements are operating system as Windows, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know about the flow of the project, these are the steps we need to discuss. The first one is importing the packages. Here we need to import the essential libraries and packages such as sklearn, clearn, matplotlib, and which are crucial for data manipulation, visualization, and model building. And the second one is exploring the dataset. Here we need to explore the dataset by examining its structure, attributes, and statistical characteristics. A thorough understanding of the dataset is crucial for informed decision through the subsequent step. And the next step is data processing. Address the data irregularities like of missing values, outliers, and the inconsistencies through the pre-processing techniques, ensuring the data integrity. And the next step is visualization using clearn and the matplotlib. Employ the clearn and the matplotlib to create the insightful visualization, facilitating the interpretation of the data pattern, trends, and the potential relationship. And the next one is feature selection. Here, we need to identify the relevant features that contribute significantly to predict the task. Feature selection reduces the noise and enhance the model performance. And the next step is data splitting to the training and the testing. Split the data set into the training and the testing subset, enabling the model training on the one portion and evaluation on the other to assess the generalization. And the next step is building the model. Absolutely, here we need to build of different types of models. The first one is random forest. It is an ensemble method that constructs the multiple decision trees and aggregate their prediction. In this project, it efficiently captures the complex relationship between the various attributes affecting the heart disease prediction, potentially leading to the accurate result. And the next one is decision tree. It is a standard model that splits the data based on the attribute value, and this context it offers the transparency and decision making, revealing the logic behind the heart disease prediction and captures the intricate relationship as effective as of ensemble method. And the next one is KNU. It stands for K-nearest neighbor. Classify the instance based on the similarity to the neighboring instance. Applied to this Excel, the heart disease prediction is influenced by nearby data points, but it struggles with the high dimensional data and might require the appropriate distance metric. And the next one is SGD classifier. Stochastic gradient descent classifier is a linear model optimized using stochastic gradient descent. In heart disease prediction, it handles large data set efficiently and adapts to changing the data patterns over the time. And the next one is passive aggressive. It is an algorithm suited for online learning scenarios where the data arise sequentially. In this project, it adapts to changing trends in the heart disease attribute over the time and offers the robust prediction. And the next one is XGBoost. It is a gradient boosting framework known for its high performance and flexibility, employed to the excel in capturing the intricate relationship and patterns in the heart disease data, boosting the accuracy of the prediction. And the next one is CatBoost. It is a gradient boosting model designed to handle the categorical features of certain attributes to the heart disease. CatBoost could effectively handle these attributes during the prediction. And the next one is off-voting classifier. It aggregates the prediction from the multiple models, and this project it amalgamates the insight from the diverse algorithms like random forest, decision tree, and others to enhance the overall accuracy of the heart disease prediction. And the last one is cascaded LSTM. It is a deep learning architecture particularly suitable for the sequence data and the context of the heart disease prediction. It leverages the temporal aspect of the data considering the time series pattern in the heart attribute, potentially leading to the accurate prediction. And the next step is user gives the input. To pre-process the input data provided by the user, ensuring it aligns with the format used during the model training. And the next step is the given input is pre-processed for prediction. The pre-processed data is to be done with the help of the user input, and it aligns with the format used with the model training. And the next step is the trained model is used for the prediction. Feed the pre-processed input data into the trained model for the prediction. Model evaluates the input data and produces the prediction. And the last one is final outcome is displayed. Display the final prediction by using the Flask as a web interface where each model will give the prediction presenting the probability and classification of the heart disease based on of the user's input. The execution of the project. To execute the project, first we need to open the code folder. And this is the code folder containing of various files within it, the CatBoost info containing of the training and the CSV file for the testing and training of the data, and the static folder containing of the assets, CSS, JavaScript and the images files within it. And the template folder containing of typical HTML documents. It typically include of home, index, results, sign-in, sign-up pages within it. And now app is an py file which likely contains the information related to the printing logic. It includes the code written in Python that handle the server-side operations such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the heart is an CSV file that is used in this project. And the model is a SCAV file which contains the algorithm information and is loaded into the project code. During the runtime, it utilize the trial model for the various tasks such as making the prediction of new data, performing the testing operation. And the notebook is an IPYMP file which contains the information on the combination of code, graph, and output all in one place. It allows the user to write and execute the code in the individual cell, making the popular choice for the data science. And the signup.db is a file appear to be the database file used to store the user information. And for the execution of the project, first we need to copy this code folder path and then open the Anaconda prompt. Here we need to write a command that is cd space and paste this code folder path. By this it will change the current directory to the code folder's path, and then write a command that is python space app.py. By using this command, it will execute the Python script and perform the runtime check for any syntax errors or logical issues. And then click on the enter button. After running this app.py file, the Flask framework will host the application locally at the default address like this. We need to copy this link and paste it on any of the web browser of our choice, and I prefer to use the Google Chrome. I am opening this Chrome and pasting this link, and then click on the enter button so we can see the title and some information about it. And then click on the sign up button. Here it will redirect to the sign up page containing of some necessary details that are need to be filled to create an account. But my account is already created, that's why I'm using the sign in button. Here it will redirect to the sign in page containing of the username and password. And then click on the login button. Here it will redirect it to the index file containing of some input details that are need to be filled, and I am entering those details. Age as of 63 and female or male. Female means of 0, male means 1. I'm entering the 1 as of male, and the CP is of 3, and the resting blood pressure is 145, and the serum cholesterol is 233, and the fasting blood pressure, if is greater than 120, then it means of true, that means we enter 1, if not then else written 0. I'm entering 1, then means of blood pressure is greater than 120, and the resting electrocardiograph result is of 0, and the maximum heart rate is of 150, and exercise induced angina, if yes then click 1, no then 0, and I'm entering 0, that means no, and the old peak is of 2.3, and the slope is of 0, and the number of major vessels is of 0, and the thalassemia is of 1, and then click on the submit button. Here it redirected to the result page, and viewing the result you have a chance of having the heart disease with the probability of having the disease is of 79%. And then click on the home button. Here it will redirect it to this page where we can re-enter the other details too, and I'm entering the details of age as 62 and the gender as female, that's why I'm entering the 0, and the CP is of 0, and the resting blood pressure is of 150, and the cholesterol is of 244, and fasting blood pressure is not greater than 120, that's why I'm entering the 0 as false, and the resting electrocardiographic result is of 1, maximum heart rate is of 154, exercise induced angina is of 1, then S means of S, old peak is of 1.4, and the slope is of 1, and the number of major vessels is of 0, and thalassemia is of 2, and then click on the submit button. Sorry, it's value that it's entered as 1.4, not as 1.4, and then click on the submit button. Here it predicted the result as of you are safe. The probability of having a disease is 31%. In this way, we can predict the heart disease using the machine learning and the deep learning algorithms. And in conclusion, the heart disease prediction model developed using the machine learning and the deep learning algorithms using the Kaggle heart data set with of 303 rows and the 14 attributes are implemented the various algorithms with of logistic regression, random forest, XGBoost, and of many more as achieve the better accuracy results rather than of the other methods. The deep learning techniques such as the multi-layer perceptron and artificial neural network also showed the good performance. However, we noted that the deep learning techniques may not be useful for the small data set. The heart disease model proposed and this project helped the doctors and the patients track the health risk based on the age and other attributes.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.